Okay, so we are going to go ahead and talk about parallel and perpendicular lines. That's section 7.1 from the book. You do have access to the pages from the book if you go to my.hrw.com, go to student resources, and look through the different units. I believe it's Unit 3 that we're in, Module 7, and this again is parallel and perpendicular lines. Central question here is, how can you write equations of lines parallel and perpendicular to a given line? So let's look at this information. Remember that perpendicular lines are two lines that intersect to create a 90-degree or right angle. Okay, so here what you're going to see is you're going to see some equations that are perpendicular to each other. What I'd like you to do here is look at these equations and determine what it is about their slopes that is causing them to be perpendicular. It is the slopes of lines that determine whether two lines will be parallel or perpendicular to each other. And again, using these three sets of perpendicular lines, can you discover what it is about those lines that makes them perpendicular? So I'd like you to pause the video here and analyze these equations and see if you can't figure out that relationship between these slopes. Okay, so in equation 1, the slope is 2. In equation 2 for problem 1, it's negative 1/2. So slope 2 and a slope of negative 1/2. In number 2, we got a slope of 2/3, and a line that's perpendicular to it has a slope of negative 3/2. As a matter of fact, any slope that has any line, that has a slope of negative 3/2 will be perpendicular to any other line that has a slope of 2/3. So the y-intercept here does not determine at all whether they are going to be perpendicular. It is solely based on the relationship between their slopes. In 3, we got a slope of negative 9/5 in one equation, and the other equation has a slope of 5/9. So by analyzing those, hopefully what you're able to see here is that these slopes are reciprocals of each other, with one of them being positive and the other being negative. In other words, their slopes are what we might call opposite reciprocals of each other. For example, the slope in equation 2 is 2/3, and the line that is perpendicular to it has a slope of negative 3/2. So you can see that this slope is positive, this slope is negative. Not only that, is the numbers in the fraction are flipped, 2/3 and 3/2. And that relationship is what is making these two equations perpendicular to each other. You see that same relationship in 1 and also in 3, equations in 1 and 3, with 1 having a slope of 2. Well, the reciprocal of 2 is 1/2, and you can see the 2 is positive, the negative 1/2 is negative. And so that is what is going to make two equations perpendicular to each other, is if their slopes of the two lines are reciprocals of each other, with one of them being positive and one of them being negative. And again, we can call that just their opposite reciprocals. Okay, for parallel lines, you can see that the equation y equals 2x plus 2 and y equals 2x minus 1 are parallel, as well as y equals 1/2 x plus 6 and y equals 1/2 x minus 2. Those two are also parallel to each other. So what is it about their slopes in these equations that is causing them to be parallel? And well, what it is that if two lines are parallel, then their slopes are the same. So parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so using that information, we can knowing that two lines that are parallel have the same slope, and two lines that are perpendicular have slopes that are opposite reciprocals, then we can find equations of lines that are parallel and perpendicular to other lines, and as long as we also know a point that the new line needs to go through. So in example 1, we need to write an equation in slope-intercept form of the line that passes through the given point, which in this case is negative 3, 4, and is parallel to the given line, which is the line y equals 3x minus 7. Okay, so we want to find a line that's parallel to this line, and goes through the point -3, 4. So using a combination of what we learned in the last unit, along with what we've just seen about parallel and perpendicular lines, we can write the equation for this line. Okay, so at this point what we need to do is find a line that's parallel to the line y equals 3x minus 7 that goes to the point -3, 4. So because these two lines need to be parallel, then that means that they will have the same slope. So the equation for the line that we're going to write needs to have a slope of 3 as well. What we won't know at this point is what does the y-intercept need to be so that this line will also go through the point -3, 4. So to find out what that y-intercept is, we can take the x-coordinate of the point -3 and the y-coordinate of the point 4, plug that in for the y and the x in the equation, and then we can now solve this equation to find out what that b value is, or does need to be in order for this line to go through the point -3, 4. So there's going to be two steps to solving for b. The first one's going to be multiply the 3 and the -3 together. Okay, and then we'll need to add 9 to both sides. Cancel out that -9, and b will be equal to 13. So the equation of the line that is parallel to the given line that goes through the point -3, 4 is the equation y equals 3x plus 13. Okay, and that could be checked with a calculator. We can go ahead and plug in that equation and then check and verify that that line does actually go through the point -3, 4. All right, for the next question, we are going to write an equation in slope-intercept form again, but this time we want it to pass through the given point, but this time be perpendicular to the given line. So we want to now be perpendicular to the line y equals 4/5 x minus 6. In order to create a line that is perpendicular to that line, what we want to do is take the slope of this line, okay, which is the 4/5, do its reciprocal. We want to do the negative reciprocal of that number. So the negative reciprocal of 4/5 would be -5/4. So the equation of the line that we need to write is going to have a slope of -5/4 this time, and that will make this line perpendicular to the given line. Now, once again, what we need to do is make sure that this line also goes to the point 5, 7. So similar to the way we found b in the last problem, that's pretty much exactly how we will be able to find the value of b for this problem. We want to plug in the y-coordinate of that point in for y, plug in the x-coordinate of that point in for x, and then we want to now solve this equation for b. Once again, it's a two-step process to solve for b. The first step is going to be to multiply the -5/4 times the 5. And by multiplying the 5 times the 5, that getting 25, then we can see that that's going to be -25/4. Okay, so, and then adding 25/4 to both sides. Okay, then using a calculator, we can add 7 and 25/4, and if we was to do that, we would get 53/4. Okay, you could write these fractions as decimals, but really since our equation had fractions in it, then we want to try to write our answer in fraction form. So then you get -5/4x plus 53/4. Okay, and so this line will be perpendicular to the given line, and as long as we did all the math correct, it will also go through the point 5, 7. Again, you can check on your calculator by graphing the line, and then we can graph, if we're using decimals, then you can also graph the point and see if that line actually does go through that point. Okay, so given a point and a line, then we can write an equation for a new line that is either parallel or perpendicular to the given line. Okay, let's look at parallel lines. So here it says, what can you say about the points on this line? All right, so you can pause here and take a look and think about that question for a moment. But what you should notice is that, or what we want to notice is that the value of y is -2 everywhere on that line. Every point on that line has the same y coordinate of -2. These 4 points, this is here 1, -2, 2, -2, 3, -2, 4, -2. Here's -2, -2, -4, -2. So no matter where you go, y is equal to -2. For that reason, the actual equation of this line is y is equal to a -2. Okay, and the last part of this is what axis is this parallel to? Well, we can see it's parallel to the x-axis, parallel to x-axis, and perpendicular to y-axis. Okay, so it's perpendicular to the y-axis. Okay, so knowing how to write equations of horizontal and also vertical lines, let me go do a vertical line real quick. So what would the equation of a vertical line be, such as maybe that right there? Well, in this case, now it's the x-coordinate that's always the same. For a vertical line, the x-coordinate will always be the same. We can see a few points here. This point right here would be the point 5, 1. Here's 5, 2. Down here, that would be 5, -1, 5, -2. And so no matter where you go on that line, now it's the x-coordinate that is always equal to 5, and therefore that is the equation of that line. Okay, so here we want to write an equation in slope-intercept form for the line that passes through the given point and is parallel to the given line. Then give the axis that the line is parallel to. So we want to be parallel to line y is equal to 6. Well, on a graph, where is y always equal to 6? Well, that's going to be 6 units up the y-axis. So 1, 2, 3, 4, 5, 6. So not only there is y equal to 6, but there, and as a matter of fact, everywhere along that horizontal line, both directions, y is equal to 6. So there's the line y is equal to 6. Okay, now what we want to do is write an equation of a line that is parallel to that goes to the point 8, 5. So I'm going to go ahead and count this off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So there is the point 8, 5. So in order to be parallel to that line, the red line, we will need this line to also be horizontal. There, and then that line is going through the point, and now then what is the equation of that line? Well, on this line, y is always equal to a 5, and so the equation of that line is y is equal to 5. Okay, and you can see that it is parallel to the x-axis. For the second one, it's x equal to 3 we want to be parallel to. So x is equal to 3 right there on the x-axis, and everywhere along the vertical line that goes through the x-axis at 3. So there is the line x is equal to 3. Okay, now then, we want to be parallel to that line, but we need to go through the point 7, -2. So 1, 2, 3, 4, 5, 6, 7, -2, be right there. And in order to be parallel to the vertical line, this line will also need to be vertical. And what is the equation of that line? Well, along this line, x is always going to have a value of 7. Okay, you got 7, 1, 7, 2, 7, -1, 7, what does that be? 7, -5. So x in this line is always equal to 7, and that is the equation of that line. Okay, so that about wraps up the notes on parallel and perpendicular lines. If you have any further questions, please make sure to talk to myself, or you can also find more resources on the internet.